Formulae, stoichiometry and the mole concept. The modern symbols, usually taken for the first letter of the element but not the case always. The first 20 elements with their symbols and atomic numbers are hydrogen, H, 1, carbon, C, 6, sodium, Na, 11, sulfur, S, 16. Helium, He, 2, nitrogen, N, 7, magnesium, Mg, 12, chlorine, Cl, 17. Lithium, Li, 3, oxygen, O, 8, aluminium, Al, 13, argon, Ar, 18. Beryllium, B, 4, fluorine, F, 9, silicon, C, 14, potassium, K, 19. Boron, B, 5, neon, N, 10, phosphorus, P, 15, calcium, Ca, 20. Symbols equations are used with reactants on the left side of the arrow and products on the right. These equations must be balanced as matter isn't created or destroyed during a chemical reaction, and hence it must be made certain that the number of atoms of all elements at each side is the same. For example, Mg plus O2 A MgO. As there are 2 atoms of oxygen, 2 must be added with Mg and MgO. The final equation would look like this. 2 megagrams plus O2 A 2 MgO. The reaction between zinc and dilute hydrochloric acid. Zn plus HCl A ZnCl2 plus H2. As there are 2 Cl and H in the product side, 2 must be added with HCl. The final equation would look like this. Zn plus 2 HCl A ZnCl2 plus H2. The reaction between sodium carbonate and dilute sulfuric acid to produce sodium sulfate, carbon dioxide and water. Now 2CO3 plus H2SO4 Na2SO4 plus CO2 plus H2O. This equation is perfectly balanced and would require no further addition. The elements are present in 4 different states in these reactions. They are solid, S, liquid, L, gas, G, and aqueous, AQ. An aqueous solution is such that a substance is dissolved in water. These states are also written with the elements in these chemical reaction for better understanding. PbNO3, AQ, plus 2 NaZl, AQ, A PbI2, S, plus 2 nano3, AQ. This shows that the lead iodide obtained in the product is a precipitate. Ionic equations. These equations only include the only ions that take part in the chemical reaction. HCl, AQ, plus NaOH, AQ, NaCl, AQ, plus H2O, L. This equation will be broken down into ions. H plus, AQ, plus Cl, AQ, plus Na plus, AQ, plus OH, AQ, Na plus, AQ, plus Cl dash, AQ, plus H2O, L. After removing spectator ions from the equation, the ionic equation would come up to H plus, AQ, plus OH, AQ, H2O, L. Empirical formulas. Show the formula of a compound in its simplest form. Different compounds may have the same empirical formula. Example, ethanoic acid has following composition by mass. Carbon 40%. Hydrogen 6.67%. Oxygen 53.33%. Solution. Divide the composition percentage by relative atomic mass. Carbon, 40/12 equals 3.33. Hydrogen, 6.66/1 equals 6.66. Oxygen, 53.33/16 equals 3.33. 3.33, 6.66, 3.3. Divide by smallest value A, 1:2:1. Empirical formula of ethanoic acid is CH2O. The ionic compounds exist as structures of oppositely charged ions. For example, in HCl, this indicates that the H ions and Cl ions exist in the ratio of 1:1. For Na2SO4, the ions for sodium and sulfate exist in the lattice in ratio of 2:1. Molecular formula shows the number of atoms of different elements in a compound. Benzene has carbon and hydrogen in the composition 92.3% carbon and 7.7% hydrogen. The relative molecular mass of benzene is 78. By using this information, we can find both empirical and molecular formula of benzene. Relative atomic mass of carbon is 12 and hydrogen is 1. Divide the composition percentage by the relative atomic mass. Carbon 92.3/12 7.7. Hydrogen 7.7/1 7.7. Divide these two numbers by the smallest one. 7.7/7.7 for both. The ratio for these two elements in the compound is 1:1. So the empirical formula is CH for benzene. The relative mass for CH is 13. Divide the relative molecular mass of benzene by the empirical mass. 78/13, 6. 6x CH6H6 molecular formula for benzene. Percentage composition. The formula for percentage composition by mass in an element is equals relative atomic mass x number of atoms of the element in the compound x 100. Relative molecular or formula mass of the compound. For example, CH4 methane, relative molecular mass is 16, 12 plus 4 by 1. Percentage of carbon is equal to 12/16 times 100 equals 75%. Percentage of hydrogen is equal to 4/16 times 100 equals 25%. The mole. 1 mole of a substance has a mass equal to its relative atomic mass, relative molecular mass or relative formula mass as appropriate, expressed in grams. For example, 12 g of magnesium would have 0.5 moles as the relative atomic mass of magnesium is 24. 12 g/24 are 0.5 moles. 2 g of H2O would have 0.11 moles as the relative atomic mass is 18. 2 g/18 are 0.11 moles. Reacting mass and volume. CH4, G, plus 2O2, G, CO2, G, plus 2H2O, L. 1 molecule of methane and 2 molecules of oxygen react to form 1 molecule of carbon dioxide and 2 molecules of water. These molecules can also be referred as moles and hence in terms of grams as per the relative atomic mass. It would mean that 16 g of methane react with 64 g of oxygen to form 44 g of carbon dioxide and 36 g of water. This proportion would remain the same and would produce predictable results. Finding the empirical formula of a compound. Magnesium oxide exists in different formulas such as MgO, Mg2O and MgO2. 0.30 g of magnesium burns in air to form 0.50 g of magnesium oxide. Ratio of the two is 1 minute and 1.67 seconds. 1 mole of magnesium is 24 and so by multiplying by the ratio, 0.50/0.30*24 equals 40 g. 24 g of magnesium in 40 g magnesium oxide, so remaining 16 g for oxygen, therefore, 1 molecule of oxygen is there by relative atomic mass of oxygen, 16. 16 plus 24 is equal to 40. Predicting the mass of products of a reaction. An equation for zinc nitrate is given that decomposes into zinc oxide, oxygen and nitrate on heating. 2Zn, NO3, 2, S, 2ZNO, S, plus O2, G, plus 4NO2, G. 5 g of zinc nitrate is used in the reaction. As per the equation 2 moles of zinc nitrate will decompose to form 2 moles of zinc oxide. The molar mass of these two, as per the molecular mass in grams, is 379 g for zinc nitrate and 163 g for zinc oxide. 163 divided by 379 times 5g is equal to 2.15 g of zinc oxide will form. Reactions involving gases. 1 mole of any gas at room temperature, which is 250 C, will have a volume of 24 dm3, Avogadro's law. Zinc reacts with excess of dilute sulfuric acid to form zinc sulfate and 100 cubic centimeters hydrogen gas. Zn plus H2SO4 ZnSO4 plus H2. 1 mole of zinc produces 1 mole of hydrogen gas. Zinc mass as per Mr. is 65.5 g al 1 mole. Hydrogen volume 24,000 cubic centimeters al 1 mole. For hydrogen, 24,000/24,000 100 equals 100 cubic centimeters. For zinc, 65.5/24,000 100 equals 0.27 g. 0.27 g of zinc will produce 100 cubic centimeters of hydrogen gas. Reacting gases only. For these reactions we will take into consideration the equation of oxidization of carbon monoxide to form carbon dioxide. 250 cubic centimeters of carbon monoxide is oxidized at RTP. 2CO, G, plus O2, G, A2CO2, G. 2 moles of carbon monoxide will oxidize with 1 mole of oxygen to form 2 moles of carbon dioxide. 2 moles is 250 cubic centimeters. By ration of 2:1:2 with 2 representing 250 cubic centimeters. 125 cubic centimeters of oxygen will be required to form 250 cubic centimeters carbon dioxide. Reactions in solution. Concentration. A 1 molar concentration of a substance consists of 1 mole of the substance dissolved in 1 dm3 of solution. Amount of substance, moles, equals volume of solution, dm3, x concentration, mole/dm3. Example. The concentration of potassium hydroxide solution is 0.10 g/cm3. What is the concentration expressed in mole/dm3? 0.10 g/cm3 equals 100 g/dm3. The molar mass of potassium hydroxide is 56 g. 56 g a 1 dm3. 100 g equals 100 divided by 56 is equal to 1.79 mole. The concentration is 1.79 mole/dm3. Example. What mass of potassium nitrate would be required to produce potassium nitrate of volume 50 cubic centimeters and concentration 0.5 mole/dm3? Volume of solution 0.050 dm3. Number of moles of potassium nitrate is equal to 0.050 times 0.5 equals 0.025 moles. Mr. of potassium nitrate equals 101. Mass of potassium nitrate is equal to 101 times 0.025 equals 2.53 g. Reactions involving solids and solutions. Example. Solid iron fillings and dilute hydrochloric acid will react to form iron, 2, chloride. How much of dilute hydrochloric acid would be required of concentration 0.5 mole/dm3 to react completely with 1 g of iron fillings? Phase plus 2 HCl, Aq, AfACl2, Aq, plus H2, G. 1 g of iron fillings would be 0.018 moles. As molar mass is 56 g and 56 g is 1 mole. The equation shows the ratio in which HCl and Fe react, which is 2:1, and so 0.036 moles of HCl would be required to react. The concentration of HCl is 0.5 mole/dm3. Which means in 1 dm3 there will be 0.5 moles. So for 0.036 A, 1000/0.5 asterisk 0.036 equals 72 cubic centimeters. Reactions involving only solutions. Potassium iodide solution reacts with aqueous lead, 2, nitrate solution forming an insoluble precipitate of lead, 2, nitrate and a solution of potassium nitrate. PbNO3 Aq, plus 2Ki Aq, PbI2, S, plus 2KNO3, Aq. What volume of potassium iodide solution of concentration 0.5 mole/dm3 is needed to react exactly with 10 cubic centimeters of lead, 2, nitrate solution of concentration 0.1 mole/dm3, what mass of lead, 2, iodide is formed? 1 dm3 or 1000 cubic centimeters of lead, 2, nitrate a 1 mole, 10 cubic centimeters a 0.01 moles. 1 mole of lead, 2, nitrate reacts with 2 moles of potassium iodide and so 0.02 moles of potassium iodide is required for this reaction. 1000 cubic centimeters of potassium iodide contains 0.5 moles and so a solution of 0.02 moles will be of 40 cubic centimeters. 1 mole of lead, 2, nitrate produces 1 mole lead, 2, iodide as per the ratio and 0.01 moles of lead, 2, nitrate must be produced. The mixture of lead, 2, iodide is 461 g and so the precipitate would be 4.61 g, for 61 by 0.01. Percentage yield and percentage purity. Percentage yield is the ratio of actual and theoretical yields in percentage. The formula for it is as follows. Actual yield x 100. Theoretical yield. For example, The ionic equation for lead, 2, nitrate with excess of potassium iodide to form lead, 2, iodide. 3.31 G of lead, 2, nitrate was dissolved to obtain 3.89 G of lead, 2, iodide. 1 mole of lead, 2, nitrate produces 1 mole of lead, 2, iodide. Pb2 plus, Aq, plus 2I dash, Aq, a PbI2, S. 1 mole/dm3 solution of lead nitrate has a concentration of 2.0 mole/dm3 of nitrate ions. Lead, 2, nitrate mixture in mass equals 331 G. Produces 461 G of lead, 2, iodide. 3.31 x 331/331 equals 3.31 G of lead, 2, nitrate produces 3.31 x 461/331 equals 4.61 G of lead, 2, nitrate. Theoretical yield is 4.61 G. Actual yield is 3.89 G. Percentage yield equals 3.89 x 100/4.61 equals 84.4%. Purity. A sample of 5 G of impure sodium chloride has 4.85 G of pure sodium chloride. The purity of this 5 G would be 4.85/5 x 100 equals 97%.